All right. Good morning, good evening, good afternoon, and thank you for joining our live stream today. Today, the topic is how to build a knowledge graph. I'm very excited about this topic, and I'm very happy to have Jennifer Reif join me today. Hi, Jennifer. How are you
Hi,
doing?
good. How are you?
Good to see you again on this stream. Good to see you join again. For people who don't know who you are or what you do, maybe do you want to give a quick intro about yourself?
Yeah, sure. So I'm a developer advocate at Neo4j and have been for several years now. And my focus is mostly on the Java tools, ecosystems, integrating with Neo4j. So anything that has to deal with Java and Neo4j is kind of right up my alley. But I branch out and explore lots of other things and the Gen AI things that are going on right now as well. So just kind of new tech. I like learning things. I have a blog and a podcast that's all tech focused as well, and just kind of share my learnings and then speak at events and conferences and live streams like this. So I'm super excited to be back.
Super. Yeah, great to have you back. I should share the link to your blog in the video channel here as
Sure.
well. So to get that out of the way, here is the blog. I'll add it also to the video description as usual. So if you see any links, if anything is linked in the session today, then I'm always adding that to the video description on YouTube. So if you want to look something up again, or if you want to click on something that we have talked about, then you should find it there. And I put your link into the description. It's a very interesting blog. You recently wrote an interesting article about it, which was featured in the Twin4j newsletter that we also send out every second week on loading data into Pinecone.
Yes.
So it was a nice overview of getting that, and the comparison a little bit about, okay, what's vector rag, what's graph rag.
Right. Yeah, I've
Today, yeah,
kind of played around with some of the knowledge graph, retrieval augmented generation stuff, and what I find is there's a lot of terms tossed out, and sometimes it's hard to keep up with even just kind of the foundational concepts. So my goal was to kind of level set a bit and talk about those foundational things, and that's kind of, I guess, what we're going to do today a little bit too with the knowledge graph and kind of step through the pieces of that, but just kind of building those foundations so that kind of everybody's on the same playing field and you can build on top of those.
yeah, I think that's always interesting. I was at a meetup yesterday, and we talked about recommender systems and comparison between traditional approaches, more or less with mathematical looking at how to calculate recommendations, and then comparing it with a graph-based approach on vectors within the graphs. So fast RP was mentioned in that, and then we talked a little bit about that. So that was very advanced, I would say, in terms of topic to look at these things. But it was also came back to the usual. And when you come to graphs, it's always okay. We build something. We connect nodes and relationships. We end up with a knowledge graph almost by default. And I think you can call it different things, but if you squint a little bit and if you look at it, I think it turns out to become a knowledge graph in the end, if it's not very specialized, I think. But that's great. I think that's a great foundation. It's a great thing to have, and that makes it so versatile and so usable in all these different fields. And obviously we talked about AI last night as well, but we talk about AI all the time. We talk about AI here on this channel a lot. GraphRag is, I think, probably the keyword that is mentioned the most since, I don't know, last year sometime. So
Yeah.
it's definitely happening. But for all of that, you know you need to do something first. You need to get your data there. You need to manage your data. You need to make it available to a LLM AI based system. You need to get it in order. You need to streamline and stuff.
Exactly.
And you can do that with different things, but obviously we think knowledge graph is one of the better foundations. Excuse me. But so if you do that, and if you want to do that, and if you think, okay, how do I do that? How do I get my first base on the line, and how do I build my knowledge graph? This is I think today going to be a nice, a good session, and that's because you wrote a book.
Yes, I did write a book. Yeah. Let me. I do have the link for that. I don't know if you have the link
I
already.
have the link as well.
Okay, perfect.
Yeah.
So we'll make sure that gets thrown in there, and I have that pulled up as well. We'll walk through some of the things there, and then just the kind of components and the tools that I'm going to use today. So,
and it's a handy guide. So it's not a don't be shocked or think, okay, wow, I need to read this huge book with hundreds of pages. So it's not the Lord of the Rings. So it's a handy little comprehensive guide. I think it's 20 something pages. So it gives you a great starting point, a great overview. And we try to, in this session today, we'll try to get your views on it a little bit, some tips and tricks.
Yep.
But as always, this is an open invite. So if you watch this live and you have questions, if you have any thoughts about knowledge graphs, if you have ideas and things you want to discuss, we can always see if there's some time. So just let us know. Give us a ping in the comments in the chat, so we can have a look at that.
Yeah.
So what's maybe before we dive into the actual contents of what the how to build a knowledge graph book is about is maybe a little bit how did you get to write this book? Was there a initial spark of making you think, okay, this book needs to happen. This book needs to be there. People are struggling maybe, or people will need some guidance on building a knowledge graph. What was maybe a little bit of the ideation behind the book itself?
Yeah, I mean, I've always really been drawn to content that, as I kind of mentioned at the beginning of this session, builds those foundational building blocks and kind of those key initial points to get you started. And then that allows you to, if you understand something really well, that allows you to utilize it and manipulate it how you need to for a variety of different use cases. So whether you're looking at a specific industry or you're dealing with a specific domain, if you understand how to fit the pieces together, then you can construct that knowledge graph to look anything that you need it to look like for whatever you're trying to do. So I really just wanted something that was kind of covered the foundations of each of the pieces of how to construct your own knowledge graph, what we actually mean when we talk about knowledge graph versus graph database versus charts versus, whatever. There's so many terms that get overloaded, I feel like. So really just breaking those things down. What do we talk about when we talk about knowledge graph? How is this different from like a general graph? And then how do you put those pieces together so that you have something of value reasonably quickly? Now, again, it's going to vary depending on your complexity and whatever you try to put in there. But at least it gives you some place to start that should hopefully be accessible for everybody to spin up their own knowledge graph and understand how it's helpful and potentially very powerful as well. So that was kind of the starting point. There's lots of content out there, but sometimes I feel like the content dives in pretty quickly, or even if they do cover the basics, they kind of skim the basics, assuming that everybody will kind of go back and do the research to pick up those little bits that they need. And I always like to approach the what if you know nothing and coming into this, how can I get you going? Yeah. And then also for those who might already know, how can I maybe add something that you weren't aware of before? How can I connect some dots that maybe weren't connected before? And that just makes those foundations even stronger. So whether you're completely new to graphs or expert, hopefully there's something in it for you to springboard off of.
Yeah, I think that's a great approach. And oftentimes, I think we have a great landscape of tools around Neo4j, a great ecosystem, lots of things that help the users, that get people started, but still. The concepts are sometimes maybe not missed, but I think it's hard that we start obviously at the next step. Oftentimes we start with, okay, now you have understood what you want to do. You have understood that a graph is something you want to do. You want to use and you want to build, and we can help you there. But sometimes for people, it's like they still don't know. What do they want? Do they need a knowledge graph? What is a knowledge graph? I heard about this term maybe, but I think it's great that with this book we can take them on this journey and say, okay, we explain to you what it is, what it isn't. Also, maybe some misconceptions also to get around for people also, that they think, okay, this will solve everything. Nothing solves everything, but
Right.
and and then you read through that and then, okay, yeah, I understand now. And this is important to then take this next step and say, okay, now you understood what's it all about, and now you can go and build something.
Yeah, exactly. I know for me, kind of coming into graphs, trying to figure out what is the value here, what is the benefit. I was very new to graphs just a few years ago. And what I found really cool is I'd had some experience with relational databases and had kind of researched a little bit on NoSQL databases, specifically Mongo at the time, just because it was kind of the new thing and a big deal at that point. And so I had kind of researched all these things, but what I found super powerful about graph and kind of eye-opening was that the things that I had so much trouble with and like beat my head against a wall with relational databases, those barriers were taken down with graph. And so I kind of had that aha moment. It's like, oh, the things that I was so frustrated with in a relational database, those problems are solved in a graph. Now, again, you're going to add some trade-offs. There's going to be other frustrations in a graph, but the things that were so difficult in relational just weren't there because it's constructed completely differently.
Yeah, I think this for me is also like one of these always, you can talk to a technical person, to a developer or a data scientist, and they will understand. And that's, for a product that is a database, that's great. I mean but it is kind of expected. But what you can do with a graph is you can take it to somebody that has probably not even an idea of what a database is or does, but you can show to them a graph, and you can say, hey, this is my data. This is what I'm looking at, and then they understand. Okay, yeah, I see what you mean here. I understand what's going on here, and then they can help you or give you pointers if they are the domain expert and say, okay, yeah, actually this is wrong.
Yeah.
Try this with a complicated, any other system, relational database or any other thing, and I would say it's basically impossible to do that because they will just not understand what's happening here.
Yeah, I remember a whole knowledge base of tables that was mapped out, and it was the paper that they printed it on was the size of an entire cubicle wall. It was huge. I mean, probably 30 or 40 tables, all the like cardinalities and everything. And I mean, it was cool to have it up in poster format, basically, but so complicated to try to weed through. Okay, how does this relate to this? How does this, this general area of the poster relate to this other area on the other side? It was so hard to kind of feed that understanding through, where a graph, I think, is a little bit more apparent for more complicated sets, for sure.
Yeah, I think that's great for that visually, but also if you look at the query language, I think that aids as well to the understandability. Of course, there is the potential, and then if you go deep, you can write complicated Cypher queries that are long and nested and all of that stuff. But generally, people, if you explain to them what to look for, at least the general patterns will be recognizable, even for people that are not writing SQL or Cypher or any other programming language or query language on a daily basis. So I think that is really great. So we have that book to help you along the journey as well, to understand the concepts, get there and start working and building knowledge graphs. So I think that's what we're going to do today. We look a little bit at the book. You'll give us a bit of an overview. We talk about some tips and tricks. If you are as again, an open invite. If you are building knowledge graphs currently, if you have some experiences yourself, share those with us. If you have some questions on building knowledge graphs, also use chat, and we can look at those throughout the course of the session.
Okay, so let me go ahead and share screen.
Mm-hmm.
Okay, perfect. All right, so I'll share this one. And this is just the book in kind of PDF form. It's a free downloadable resource on Neo4j site. The link was put into the chat by Alex, so thank you for that. And it just kind of covers a little bit of, there's the kind of the table of contents, but it just talks about what actually is a knowledge graph, goes through building and querying a step-by-step process for how to spin up a Neo4j instance and create an account for that, then creating a data model to start off, loading data into that. We start with structured data, which we'll talk a little bit more about, and I'll kind of show a few things there. And then querying the knowledge graph, how you construct Cypher queries, the general patterns and things you want to look for. Talking about match and create and merge. Those are kind of the three key, I would say, starter clauses you'll need. And then expanding that. So going into kind of a next level, once you have something with your graph, what do you want to do with that? So it talks a little bit about how you would look at unstructured data. That's incredibly important, especially now as we start looking at generative AI and how you incorporate AI into knowledge graphs. And then actually loading some unstructured data, and then looking at potentially some graph algorithms with our Neo4j graph data science library. And then talks a little bit about some use cases and design patterns, specifically just 3 that are listed. Goes into detail on some different, just even within those use cases, some different problems you can solve, some different analysis that you can run to ask certain questions, and various perspectives on the same domain. And then just some resources past that point as well. So starting off to build the knowledge graph, it looks at like a healthcare data set, for instance, and healthcare sometimes is very siloed. You have one appointment with this doctor here, you have one appointment with this doctor here, you'll get diagnoses and prescriptions and stuff. And a lot of times doctors don't communicate with one another unless you select for them to share that information, of course. To kind of avoid some privacy law issues and all of that. But as you start kind of building this comprehensive patient journey, basically, you can really start understanding better about a person's health, because oh, they're on this prescription that would react with this other prescription. We can't provide that, so let's try something else. Or they're already being treated for this disease. Can this other symptoms they've come up with, can that be treated with the existing stuff, or do we need to do something new? So just kind of walk through an example of when you start pulling data together, what's traditionally been siloed, when you start pulling these knowledge sources all together, how powerful that can really be for providing better and more complete solutions. In this case, of course, in a healthcare journey, but there's lots of other options too, for like e-commerce, which is the example we'll look at here in a few minutes, fraud detection, and so many others. So it talks about the pieces of a graph. You have nodes, which are the entities or the objects, if you want to think of them like nouns in your data model, for instance. So you might have people, you might have diseases.
Do you want to zoom in a little bit, Jennifer? Maybe show it a little, if that's possible.
Yeah, I think it should be. I just got to figure out what the keystroke is to do it. Nope, it doesn't want to let me. Oh, I can't figure out how to do it.
I can try to zoom in a little bit from.
Let's see. Hang on just a second here.
Yeah.
Keyboard shortcut.
I can do it a little bit here.
Oops, let's see.
No, I think that's, yeah. Here it is. Okay.
Now I've kind of like muddled my, how did I do that?
No, the little magnifying glass. Yeah.
That's better. Yeah. And there should be a way to like, I don't know what it's doing now. No. Hang on, let me just see. If I can... Oh no, it's zoomed my whole screen. That's what it's done. 1 second.
Oh, okay. Sorry.
No, that's okay. I need to practice this, I guess. If I zoom out. Okay, so on this, I gotta be on the right tab, I guess. There it goes. That's better. Okay, so that should be better. Yeah, there should be a key I have to press in order to zoom, and I can't remember which key it is.
Yeah, no problem. I think it's maybe Command plus or something, but I can zoom in a little bit here from my side, and I think that should be okay.
Okay, sorry about that. Whoops. Oh, that's not what I wanted. There it goes. Scroll changes the pages.
Yeah.
Okay, so so your components of the knowledge graph, and then of course you can categorize or group those entities into, for instance, patients and diseases, and that just helps you kind of categorize, and you can almost kind of think of it like a table organization where you have all the people listed on that table. You're kind of doing the same thing. You're attaching a label or a category to specific nodes for patients and for diseases. Then you can create the relationships between those entities. And what I really love about graph is that you're not just saying that two things are connected. Like in a traditional table structure, you see a foreign key and you understand, okay, these two tables are connected somehow, patient and disease. But you don't know what the relationship is between patients and diseases. Maybe they've researched those diseases. Maybe they've studied those diseases. Maybe they have specific specializations for those diseases. But no, this is telling you, no, this person, this patient is actually diagnosed with this disease. So it tells you, oh, they have this condition. They're living with this condition. They're treating this condition potentially. So again, all different types of relationships that you can have between a patient and a disease, but the graph actually tells you, no, this person is diagnosed with this disease. It qualifies exactly what that relationship is. Same thing with a patient and a prescription. Maybe they've taken it in the past. Maybe they administer it to a friend or a family member. No, this patient is taking this prescription. It tells you that relationship and what it all entails. And then, of course, as humans, we understand, oh, a patient taking a prescription, that means they're ingesting it somehow. They're using it to treat some kind of medical condition. And then you can add properties. So metadata, think key value pairs, if you will, for just extra information or context about those entities. For instance, a patient might have some symptoms, or a disease might be connected with specific symptoms. You could have a patient might tell a doctor on a particular day about that symptom, so they could note the particular date or record that particular date that it was noted, or that the patient surfaced that symptom, and lots of other things. Or you might have some symptoms that are stronger or more likely risk factors than others. So you could include like a weight or a percentage on how often the symptom appears for this disease, and so many other things. So all kinds of extra information and context you could store inside the knowledge graph to help you understand how these things are connected. And then, of course, you can build out even further. So for instance, you might have some sort of what the book calls an organizing principle. And when I first came across the knowledge graph definition that Neo4j has been using, I kind of looked at this organizing principle going, well, that seems kind of silly. Aren't knowledge graphs by default, don't they kind of always, categorize or group things? But we do actually have some instances where people very basically use it as a transaction system. So there is no organization or grouping, for instance, of particular categories or entities into, I guess, some kind of categories. Where here, for instance, diseases might be categorized. In this instance, it says chronic diseases, or maybe they're, like for a flu, it would be very temporary. You might have risk factors that might put the patient at higher risk for certain diseases, and so on. So you could group your data by lots of different, I guess, kind of categories or groups, or however you want to think of that. Organizing principles is how we term them. And so just a way to organize the data a little further into smaller groupings that then you can connect and kind of analyze and run additional analysis on. So that is the difference with a knowledge graph that we have highlighted. Is usually somehow with a knowledge graph, you have some sort of categorical or grouping structure that, for instance, you might organize people by their addresses, or you might organize them by particular product categories, for instance, or production stages for when a product goes from raw materials to, on shelves. So there's a variety of different ways you can organize your data and create organizing principles, but that's generally the differentiating factor of a knowledge graph versus just a transactional system, if you will. Then we dive into actually building and querying it. So we start by creating a Neo4j account. We start with Neo4j Aura, but of course there's lots of options. If you don't want to go cloud, we do have a free tier on our Neo4j cloud. That is a nice option to get started with. It is forever free. You can load data in, you can clean data out and reload new data. So lots of options there. And it is fully managed by Neo4j, which is kind of nice. I find myself gravitating toward that option a lot. But we also have Neo4j Desktop, which lets you run local instances. We have Docker containers as well that you can run. So again, full gamut there. But it walks through how to spin up an Aura database. Shows you how to sign up and how to verify your account, then actually creating the database instance, which has actually changed just a little bit. They've actually improved the Aura user experience a bit, where they walk you through a little bit more. It's a bit more prescriptive on creating the instance and spinning something up. So some of these screens might be just a little bit different now. But then you get to, once you have an instance, free instance spun up, then you actually start by creating the model. And this has slightly been tweaked too. Again, it's a bit more prescriptive, but they give you some options. You can create the model manually, and this is exactly what the eBook here is doing. It's showing you how to create a model manually. But they also, if you import the CSV files that are shown in the knowledge graph book, then you can also have the schema inferred from the CSV files, which I found to be not quite as custom and clean as I would like. So that was probably my least favorite option. And then the third one is to actually have generative AI generate the schema for you, which I found actually to be very good. I was rather impressed with how accurate it was. It pulled from the CSV files that I had dropped into the spot here. It says, CSV, and it walks you through how to do that in the ebook, I think on the next screen. But it will use generative AI to look at the CSV files and then to kind of put in a inherent schema. And it did a really nice job. There were a few things I had to tweak, but mostly it did a good job. But you can also do it manually too if you want something very custom, which was nice. And yeah, so I can actually walk through a little bit of this live. It shows you how to map. The thing that I found super helpful is the book walks you through a very manual, here's how you draw the model, and here's how you add from the UI each of the fields and properties that you need. I actually found it really nice to use the map from table. Let me see if I can jump over to that screen and we'll showcase that. So I have a couple of instances running. I'll talk a little bit about why I have a free instance and an Aura Pro trial. This is a free instance right now as well, but it's a 2-week trial. And I can actually make this bigger so it's a little easier to see. I'll talk a little bit about that in just a second, but I do have both of these up and running. So if you go to the import, I already have a custom model dropped in here. So let me just see if I can delete these pieces and walk through exactly how to do this. So I'll just delete that and see here are the 3 options that show up. So define manually, generate from schema, generate with AI. Again, the AI model did a pretty decent job, but we'll just start manually just to walk through exactly what the knowledge graph ebook is. And this already has my CSVs dropped in here. So you can either drop them in or you can browse your local computer. I do have a link to, this is the data set. The CSVs are inside this data folder. Wait, that's, maybe it's import. Yeah, here we go, import. So this actually includes a few extra CSVs that we don't use in the ebook, but the ebook will tell you exactly which CSVs to download from this repository. And this is just an e-commerce data set. So you have customers and orders, products, suppliers that supply those products, and then products that are grouped into categories. So this is our organizing principle up here. So hopefully we can drop this link into the chat as well. Just this Neo4j graph examples, Northwind. Yeah, I can send that over as well if you need it, Alex.
I should have it, but if you have, yeah, I have it here.
Yep, I will drop it into Slack.
Okay, thank you.
So yeah, not a problem. So that is kind of the starting point. So I've already loaded my 6 CSVs into here, and you can just browse and pull it in from any local. Once you download from GitHub, you can pull those in. And we'll just start by defining the model manually, as the ebook kind of shows. Let me go back into full screen mode here. And let's see, we can minimize that. So we have a little bit more screen real estate here. And our first one, we might want to start with customer. And then we have a customer that purchased an order. Now, there's lots of options that you can go with on a relationship between a customer and an order. Maybe you want to track open carts. For instance, people have added things to their cart, but they haven't gone ahead and clicked that order button. I know a lot of you probably have experienced where you'll throw items into a cart at some retailer and they'll send you an email and say, hey, you still have some great things left in your cart. Do you want to order now? So this is, you might be able to say, hey, customer has created an order, or they've opened an order, but maybe they haven't actually purchased and hit that order now button. So you might want to track this relationship differently. Maybe you just want to say a customer created an order and they have some open orders, and you might want to send emails based on that data. Or no, they've actually purchased the order. So we actually need to fill these orders and send them over to our logistics or our shipping or warehouse or wherever it is to actually fill those orders and ship them out. So again, lots of different types of relationships you could store here, but we're going to say a customer purchased an order. And then from that order, they'll order particular products. So you might want to make sure that you have the things that customers want available in your inventory. So you'll have products and order, maybe orders a product. Again, several different relationship things you could have there. We're just going to kind of stick with this one. And then I'm going to zoom out a bit so I have some room. And then we might want to say, okay, we have a supplier that's going to supply this product. So we might want to keep track of, maybe we want to track logistics or supply chain management, or maybe some bottlenecks of certain things. So we might want to track that information. And I'm going to switch this direction because I want to say the supplier supplies a product. And again, this really kind of depends on what you find to be the core starting point for your domain. For instance, if your use case is supply chain management, you may want to flip this relationship and focus on the products. maybe stocking and inventory, or maybe you'd want to focus on suppliers and the full like supply chain, where things are coming from, sourcing information, and lots of other details there. So really, the direction of the relationship type is really going to depend on the domain and the use case that you're working with. So supplier supplies product. And then we want this organizing principle. We want to be able to track products in different categories. So we might want to find out, okay, how's our produce category doing, or our seafood product category, and what are all the products that are within that, and maybe run some analysis on that. So this is where organizing principle comes in. And I'm going to say a product is part of a category. Again, lots of different things you could do there. I didn't save it. There we go. So now you'll notice, you might have noticed that when I spun this up initially, it had some little green check marks. That's because I had mapped this model to the flat files, the CSVs, and I haven't done that here. So now I'm going to actually do that. So we have customers. We're going to map that to the customer CSV. And it has this lovely little map from table, which is the thing that I like to use. So I'm going to pick the customer ID, the company name, and the city where that customer is based. And I'm going to map those things. And it automatically does the type, the column, and the property name here, which is super nice. And you'll see that little green check mark appears saying, hey, you've mapped this to the tables. You're set there. I'm going to do the same thing for orders. So map from table. I'm going to do the order ID, the order date, and the shipped date. So we might want to find out when an order was actually shipped versus when they created the order. Maybe we want to reduce the time, the turnaround time that it takes for our warehouse to fill those or something. I'm going to go ahead and do the nodes first, and then I'll go back and do the relationships. So product ID, product name, and let's say unit price there. Category, we'll pick the categories here. And we're just going to do the category ID and name for that one. And supplier, the suppliers table. And we're going to do the supplier name, our supplier ID, the company name, and the city. So similar to our customer and that, just the supplier information. Okay, now we need to map these relationships. So I believe, let's see, customer to order. I think that's on the orders table, if I remember correctly. So the customer ID and the order ID. So you have to select exactly which fields you need to map from one relationship to the other. So it knows how to do that. Customer purchased an order. When an order orders a particular product, that's on the order details. So order ID, product ID, and we might want to map how many of that product they ordered. For instance, you might order, two loaves of bread, or you might order 2 pounds of strawberries or something like that. So you might want to track the quantity that they're ordering and check that against inventory levels. So we'll put that on the relationship. A product is part of a category. So let's see, I think that's under products, I believe. So product ID and category ID. Perfect. And we don't need to map any of that. And then I think that's also on products, if I remember correctly. Oh, supplier ID. Yep. And then product ID. Okay. And now we have all these lovely little green check marks. Everything looks good. We can run the import. I don't think it generates duplicates. Hopefully not. But that only takes a few seconds. I had once where it's like 4 seconds. I've had it where it's 1 second. This only took 2 seconds to complete. And it shows you like results. There's 91 rows in the customer CSV, set 182 properties. And again, for each of the CSVs and the relationships and node types there. So we can explore the results then. Let's see, new scene. So it'll update that for me. So this is Neo4j Bloom. It's under the Explore tab. So we were under the Import tab. That's where we had our data model. Yep. So that's where we were. And then there's lots of tool options. So Explore is where we had just landed. It kind of pops up automatically with a general graph, and we can just kind of poke around on this if we want to. The ebook doesn't really go much into Bloom. It talks a little bit more about querying and kind of the technical aspects of that, but this is another option out there. It searches via natural language, so you can select different node types and relationship types and kind of search the graph that way, which is kind of a nice just explorer tool, I guess. So we see here just some categories and some products. This particular little subgraph here has a category and orders and the products that relate to those. So that's kind of fun. But let's dig into the queries, because this is where the knowledge graph ebook kind of focuses. So for instance, we might want to just see what the data actually looks like. I like to run this apoc.meta.graph. That's an APOC procedure. And don't mind some of these extra entities. This is when I pulled in the knowledge graph e-builder or knowledge graph builder, which I'll talk about in a second. When you load in unstructured data, it adds some additional metadata stuff into that. But we have customers. This is also a knowledge graph builder. So this was the data model that we pulled in. We have customer, purchased order, orders, product, part of category, and a product is supplied by a particular supplier. So we can kind of see this. This is actually how the data is stored in the database itself. So what I love about graphs and knowledge graphs is that the way that you model the data on the whiteboard or on a piece of paper or in a modeling tool is how the data ends up getting stored. So it's very visual. As Alex was talking about, it's very easily understood by technical and non-technical users alike. And it just makes it really easy to comprehend what the data is doing and what it looks like in real life, as well as actually in the database. That's the thing with a lot of different databases. You have kind of a mismatch between the way the data is actually stored and the way it exists in the real world. So there's usually some sort of mapping that has to go along with that, or some things you have to kind of cram data into unnatural formats. The graph models data as it exists in the real world, which is a very natural and visual, easy to understand way. So the first thing we might want to do is just pull back some pieces of this graph. And one of the phrases or clauses in Cypher that you will use is called match. And that is kind of like a find, or if you have a SQL background, it's like select. And so match just finds patterns that I'm going to specify. To start us off, maybe I'd want to look for products and just find a few products. And let's return a few of those products. And I think we have just under 100 products out here, but I'm just going to retrieve 10. And let's find a few. So we can click around on these. You can see properties pop up. Remember, I had mapped the product ID, the product name, and the unit price for that product. So you can see all of that data is there. It got mapped, it got imported, but we didn't really specify anything graphy, right? We didn't specify a pattern. We just specified an entity. And I can do this very easily in any other type of database. So let's actually start looking at where the knowledge graph starts benefiting, which is when you start specifying relationships. For instance, I might want to find products within a particular category. So part of, let's say, a category. So the relationship here is, if you remember our data model down here, product is part of category. Yep. So when I specify that in the actual query, product, part of category. So again, Cypher is very visual. It's based on ASCII art, so it looks very comprehensible. Don't be fooled, it's pretty powerful, especially with some of the like pattern comprehension and subqueries and things can get pretty hairy pretty quickly. But it is, for a lot of your introductory queries, it is very readable. That's one of the things I love about it. Yep. So, okay, we might want to say we want to find products in, let's say, the beverage category. So we have a category name. That was the property we saved there. And we have beverages as our category name. And then we're going to retrieve the products, the relationships, and the categories. And let's see what we find. Okay. So here we have our beverage category node. And then we've got all of the products that are part of, that are categorized basically in the beverages category. So we have a lumberjack lager, we have a coffee, we have Sasquatch ale, all sorts of chai. So lots of different options there. So that's kind of fun to just explore. But again, nothing super complicated here. This really would not be too difficult of a query in most databases. So let's take this one step further. let's say, for instance, that we have the coffee product, this iPo coffee that we have over here. Let's say it goes out of stock. And let's say we need to figure out which customers created orders for that iPo coffee product and let them know, hey, we're out of stock of this. Would you like, the secondary option, or would you prefer to wait until this comes back into stock? So let's look for customers who, let's see, purchased an order that contains, let's see, orders a product with a product name of iPo coffee. And let's see, there's part of, so it has a category. And let's say we might want to pull the supplier for that information as well. So we have a product. Actually, maybe we don't want to go quite that complex just yet. Let's just start there. So let's return our customer name, the company name. Maybe we would want to count how many orders that person has out with the coffee product on it. So count O as order count. And let's say we want to pull together all of the order IDs so that we would know which orders to update in case of changes or backup plans or something. Let's call those orders. And let's say we want to find the ones that have the customers that have the most orders with this product first. So we would want to order by the order count, which is here, the number of orders. And we want to do that in descending order so that we have the highest order count at the top of the list. So we start with those customers first and then move down the list. So we see, okay, we have, these are our the customer names. And you can see, okay, these top two have 2 orders out with iPo coffee on them. Here are the order numbers that we would need to go in and update in case of backups, or we need to send emails to these customers to say, hey, what would you like to do about this, out of stock item? And so we can do that really easily because we can specify in this graph, hey, we have this pattern within a particular product name, a pattern that product falls in. And we want to find out the customers, the orders that are affected and the count of them, as well as the actual order ID so that we can make changes and updates for that. Maybe we would want to look at, similar products that are close to that or something like that, recommend other things they might want to choose from. So there are lots of different options that we can utilize this same query to handle those problems. But again, this type of query would be a little bit more complicated in other types of systems. We could do one more that takes a different perspective maybe. And that is, let's say you're looking at some supply chain stuff and you have weather, either good or bad weather that affects some produce crops. Either you have a higher yield or a lower yield. And so it might affect some of your products. So let's see, we have customers and I'm just going to kind of copy paste for simplicity's sake. This piece, and we don't want to mess with the iPo coffee anymore, but we're looking at a particular category of the produce. So for instance, bananas had a rough year or apples did really great or something. We could look at this a little bit. And then let's say we want to pull in the supplier information for this because we want to know how does our supply chain look, what might be the impacts if something goes wrong. So we need to specify, okay, we have products and those are, there we go, supplies and a supplier. And then we would want to, let's just say we want to return that graph so we could explore it and just look at it a little bit. So this is the data that comes back, again, in a visual format. Now, just glancing at this picture, there are 5 products. So those are in purple, 1, 2, 3, 4, 5. So 5 products that would be impacted by something going wrong in produce. Here's the category node there in brown in the center. And then you can see we have 5 suppliers. So if you look, we have a product with one supplier, a product with one supplier, product, one supplier. Now, this might be a good thing because we can see that we don't rely on one supplier for lots of different products. We have a one-to-one relationship there between product and supplier. So we don't have, this supplier, for instance, supplying these 3 products. So if this supplier has problems, then that knocks out a bunch of our products. So that's good to know. But on the downside, we also don't have multiple suppliers for the same product. So we don't have backups. So that would be a high risk mitigation strategy, right? We would want to look at, okay, if something goes wrong with the supplier, let's say they have, in this area, they have a really rough year for this type of produce, that would impact this product. Well, that would completely remove it from our shelves. We don't have any backup plan. We don't have a backup supplier that might also be able to provide either something similar or the same product. So maybe we would want to look at adding more suppliers as a way to reduce bottlenecks or potential problems if something goes wrong with a specific supplier. And then you can see we have some orders in the green that would be affected if we had something go wrong in produce. And we have about 63 customers that would currently be affected by that as well. And of course, the 1 category node there in the middle for produce. So again, just a high level visualization. We can start to pick apart these patterns that are very easily comprehensible in a visual format, or we could construct queries as we did before, where you're pulling back specific customers and IDs and able to reach out to them based on problems you want to solve. So lots of options here for exploration and analysis.
Very cool.
Questions at this point, Alex, so far?
No, particularly not to you. I think looking at the time, I was wondering if we can talk about a little bit from your experience. Now we've seen how easy it is to get started. I think within almost less than 30 minutes, I think we had from nothing. We have now a working knowledge graph. I think one of these myths or one of these misconceptions, maybe, oh, this is difficult, this is complicated, especially with the powerful one-to-one mapping of data model to actually how the data is stored. I think this is one of the plus points. I was wondering if there is any other myths around knowledge graphs or any other misconceptions maybe you are aware of that you think people are maybe that's holding them back or holding them off from looking at knowledge graphs, or maybe people are confusing things what a knowledge graph is. Maybe we could talk a little bit about that.
Yeah, absolutely. So the biggest thing I would say, it's kind of two opposite ends of the spectrum, I guess it would be. So some people, I feel like they look at any new technology, and I'm guilty of this as well, or newer technology or something they haven't played with before. And they go, ooh, this is shiny and new. I want to toss it at everything. And so they really just want to know, how do I use this? How do I do something with this? And I think it's really important to start first with some sort of problem. Maybe you're struggling with a particular domain in a particular other type of database, or maybe you just haven't found a good way to design a particular system and you're really looking for a better way to do that. So come with some sort of problem. Know what you want to ask of your data set or the problem you're trying to solve. I think that's a great starting point. If you don't, not to say that you can't just toss some things in and just see where it ends up, but I feel like that approach, you're probably going to end up refactoring your data a lot more because you're trying to find the problem in some data set. You still can go about it that way, but it's going to be a longer road and more refactoring that you're ending up with. The nice thing about Neo4j is it actually does make refactoring relatively easy to do, but it is a little bit more work rather than just defining what you want up front and getting it in and then off and running with some value from there. So know what you want to ask of your data set, I think, is a great place to start. On the other end of the spectrum, I think you have people who are like, well, I'm comfortable with this particular database, and graph is another type of database. And database for a lot of people means daunting, right? It's a lot of work, it's a lot of setup, it's, a lot of modeling, a lot of, constraints and good data practices and all that sort of stuff. So it seems a little daunting to add a new database into the mix. But what I would recommend is start with something like this book, or start with our Aura free tier, where most of the database stuff is managed. And then you're just kind of playing around with data. And we have a few predefined data sets. So the Northwind one is what the eBook focuses on, but there's lots of others out there in that GitHub org too for like network management, fraud detection, and Panama Papers and all sorts of other things that you can just explore data. And if you have something to kind of poke around on and play with, I think that is a low-key way. You don't need to rip and replace a database. But to learn something, we try to make it as easy as possible to get up and running with it. And it just gives you more options. When you do run into a scenario where a particular database or a particular method or design principle doesn't work, then you have lots of options to fall back on. And you're like, well, maybe graph would. Let's try it. I go, okay, that works. That great. Now I have a fantastic solution that works for me using knowledgegraph. Or hey, knowledgegraph didn't really work for this. Let's try something else. It gives you more options. So I think for those of you timid to start with a new database, we try to make it easy. Just hack around on it and see what you can find. For those that want to apply graph to everything, it is not a silver bullet as with all technology. But kind of poke around, see if there's a struggle point or a particular domain that's tricky, as it is in some other type of data store, and try to solve those problems with graph. And I think you'll end up with a good outcome for those two things.
Cool. Yeah, I think that's great pointers. There are two more questions, or there are a couple more questions, but I think two questions are going into a little bit of the same direction.
Okay.
From Complete and from 4G on. Complete asks, are there particular standards for naming, nodes and relationships? Is there, you have showed something here on the Northwind dataset. Is there a standard way of naming things, and the question that goes into that, is there a schema that needs to be defined and to follow along, or is it how do I set my graph basically?
Yeah. So we don't have restrictions on naming. You can use just about any naming convention you want to. We allow most things. I think I won't completely say that. I think there are a couple of things that are required because you can't use like Cypher keywords and such. If I can get this to minimize. But let's see. There we go. Let me just pull up. There is a Cypher style guide, I think it is. And it will, yes, perfect. So it walks you through, like, we recommend your relationships are all caps with an underscore in between and those sorts of things. So it just kind of makes, when you write Cypher queries or when you set up your data model, it makes it easier to look at because there are kind of conventions that we recommend or best practices, but we don't restrict if you want to move outside of some of those conventions. Again, there's certain things like you can't use keywords and such, but outside of that, it's pretty flexible. As far as enforcing a schema, so Neo4j, most graph databases are known for being schema optional, schema free, schema flexible, however you want to term it. But that doesn't mean there are no restrictions that you can't put in. It just means that you need to have some sort of data governance practices. Like, we don't want this property to look anything different. We want it to always be unique, or we want it to always exist for this type of node. You can set up constraints for those sorts of things that require certain aspects of the data model to always be there or not. So it really just comes down to, at that point, domain experts determining this is what we want the graph to look like, and we always want it to look like this. We don't want there to be kind of differentiating, factors that get added in or something like that. So you can set up constraints to control some of that, but we let that be up to the user rather than constraining it at the database level, if that makes sense.
Yeah, no, that makes sense. I think we have a couple more questions. I think one came in from Antonio, I think goes into the AI direction. Is a little bit, he says, I want to use knowledge graphs for agents. I think you can maybe extend that a little bit to, okay, how do knowledge graphs and AI, whatever, work together? Is there something you can talk a little bit about?
Sure. Yeah. So generative AI adds another layer of complexity onto things, but a knowledge graph as a kind of data source or in retrieval augmented generation, which we talk about a lot at Neo4j. So it basically is just using the knowledge graph as a data source for the large language model. And that actually really increases the accuracy and the relevance of the data coming back. When you ask it a question, it goes out to the graph, finds similar entities to that question, pulls the related context or related connections based on the relationships around those similar points, and pulls that back and then sends that to the LLM to generate an answer. We have found that you get much better responses, more context, because again, you're storing those relationships in the data itself. So it pulls all the relevance and connected entities around that to the LLM as context. We also find it to be highly explainable. So an LLM, it's really hard for you to understand where the LLM got an answer because it's kind of a black box. It's based on probabilities and it's training data and so on. But with a knowledge graph, you can look at the data that's being sent to the LLM. You can go back to the knowledge graph and run some data analysis queries and say, okay, here are the entities it pulled back that were similar. Here are the connections it got around those entities. Here's how it's getting this answer, or here's how it's putting the paragraph answer or the image or something together, because it's constructing that based on this piece of the graph. So it also adds to the explainability of it. So I really like using knowledge graph as a data source for retrieval augmented generation. And then, of course, you pile on another layer of stacking agents. Now, what agents allow you to do is use GraphRag, for instance, a knowledge graph as a data source for RAG. You could also have an agent that goes out to your payroll system, or it goes out to your travel system, or it goes out to whatever. And when you ask the LLM to do specific things, it could use the knowledge graph for certain things as an agent, but it could also have agents to all these other systems to read and write data back and forth and kind of pool all that information together as well. So a knowledge graph, again, isn't the only solution. You can have some things in a knowledge graph, and then you could have other systems that are in other things, and you can use agents as kind of a go-between to all these different systems to, execute tasks or to pull back data and, kind of create this very comprehensible answer. I hope that kind of gives an introductory overview without going too much into the weeds.
No, I think that's great, and maybe that's another good way for me to highlight our Graph Academy courses. There is one building knowledge graphs with LLMs. I think that is something that also is mentioned in the book, and you mentioned this earlier about that you can use an LLM to create your knowledge graph. I'll share the link in the description as well. But there are lots of other great use cases and great learning courses on the Graph Academy. So I think that's a good way of diving in there.
And for just resources on agents, I know Neo4j has put out a lot of blog posts, probably videos too, recently on working with agentic systems and knowledge graphs. So feel free to check out either our blog or our YouTube channel. There might be some things out there for you.
Totally. Yeah, there's lots. I think we are already over time, but I wanted to highlight or talk a little bit about one more thing, because it came up 2 times now, is about properties and amount data that you can put there, and if you have to decide on a type of property you put in on a relationship or on a node, and maybe we can quickly clarify that you can put almost as many properties as you like to each relationship and to each node, and it's up to you what you want to define and put there. And you have different types as well. There's support for geospatial, there's support for time and date, there is support for strings and other values and types. Exactly, that's the page. So you have great possibilities to put the data there. You can identify what you are looking at, what you want to put in your knowledge graph, and then you add the values to your properties, or your the properties to your relationships or to your nodes indeed.
Yep. Yeah, absolutely. And I would reference this for all of the data types that are possible. There are a few kind of caveats and best practices for you don't want too many properties on nodes or relationships, because that makes filtering and querying really difficult. Again, where Neo4j draws its power is the nodes and relationships and the patterns within those. So oftentimes, if you're filtering a lot on specific property values, you may want to make those separate nodes and actually just filter that through patterns rather than filtering based on property. So there's a few little things that you want to kind of optimize for as you get comfortable with modeling. So I would just say, try to steer clear of overloading nodes and relationships with probably 20 or more properties. But if you kind of stay within that and use some filters, for good optimization, I think you'll come out with these good performance on that.
Yeah. and for a start, because I see here the question from Rodrigo for a no-code or a low-code tool for querying, I think you might have just missed Jennifer showing the Explore tab at Neo4j Aura, where you here it is again, where you can use in natural language to search for patterns. You can move around the graph and get some analysis that going. So it helps a lot with that from built in directly in our tools. But then there are other third-party tools you can also use and look at. So there's a pretty strong ecosystem around Neo4j that helps you without having to write lots of Cypher. So here you see this pattern Jennifer just written is without any Cypher query. You just clicked it together basically. So there is some possibilities there as well to do that.
Yep. And there's also like if you use our LLM graph builder, you can kind of chat a little bit, and there's some kind of large language model tools as well where you can ask it questions and it will write queries and retrieve data for you. So that might be another option. Again, a little bit more complicated there, maybe to construct and build custom, but that might get you going for very specific use cases as well.
Yeah. I think that's a great shout out. I'll add the graph builder here in chat as well. I think that is a great resource if you want to get going. If you have interest now, if you're a little bit curious of how to get going, but don't really want to dive in all the way to Cypher, then the knowledge graph builder application web app is a great tool you pick a couple of sources, you pick a couple of things, and you get a knowledge graph pretty quickly.
Yep, and the ebook kind of touches on the knowledge graph builder, but doesn't go into detail there. So if you have questions, feel free to reach out to somebody.
Reach out to us. There's some great documentation, some great resources around the graph builder as well. So you should be finding that pretty helpful for you. All right. So quickly, Tyler, no, there's no negative effect on taking properties and making them their own separate nodes. I think it depends a little bit on your model, like what Jennifer said. If something is queried often, and if you go through something often, then it probably makes sense to make it as a separate node. If something is not as relevant and only comes up every now and then, it is fine to have it as a property. It is a bit depending on your queries, on your use cases, but don't fear if you afterwards realize something has been made a property and you think now that it should become its own node. You can always refactor your graph, and it's not as complicated, not as hard to do as with relational database. So graph brings lots of flexibility here, so you can always change that later if you realize, maybe that should have been its own node because you're querying that particular property a lot of times.
Yep.
Cool. I think we're out of time. So thank you very much for your questions. Thank you very much for sticking around, and hopefully now go and build your own knowledge graphs. I think it was great. Read the book, have some fun, try it out. Don't be scared. It's easier than you think to get started. So thank you very much, Jennifer, for explaining this to us, for writing the book, obviously, and for the great guide today. If you are interested in more Neo4j, then I'll invite you to Nodes 2025. I know it's in November, so it's a long way away. But if you are interested in presenting, maybe we are having our call for papers open until 15th of June. So if you have a story to tell about Neo4j or graphs or AI and graphs or knowledge graphs, and pretty amazing whatever you have in store, then please submit something for that presentation, for that conference. It's virtual online.
And
so
even if it's just your experience with walking through one of the tutorials or the ebook or something, I mean, anybody's perspective is of value. Somebody else has probably hit the same, bumps or traps or whatever that you have run into. So sharing that is always of value.
Exactly, and there is lightning talk sessions, so 15-minute sessions. So maybe that's a great thing to share your experience and your path to graph, basically, a little bit, and give some pointers what helped you and what made you successful. So that would be great. And what next? I think we mentioned Graph Academy, we mentioned Aura Free. So these are great resources to learn more, to experience, to try it out yourself. If you have any questions, any need to change or exchange yourself with the community, then please check our community pages on our developer hub. There is a Discord server, we have a community forum, lots of people who can help you, and you can bring your questions, bring your ideas, but also help other people or just chat about graphs.
Yep. Thank you so much for having me.
like Simon. that helps a lot. Yes, that's a great point. Yeah. Cool. Yeah, with that, thank you all for watching today. Thank you for participating. Again, thank you very much, Jennifer, for writing the book and for giving us the demo today. And hope to see you soon at another Neo4j live stream or somewhere around the globe on an event. Have a good rest of your week and take care.
Cheers.